students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as determinants. Let's see properties of determinants. Find the value of 1, 2, 3, 1001, 2002, 3003, 11, 12, 13. Now here you have to find this value without actual multiplication. Now how do I do this? Guys, how do we see let's see how do we do a sum without actual multiplication. Initially assume the sum to be D. 1001, 11, 2, 2002, 12, 3, 3003 and 13. Right? Now what you have to do is, guys, I have to either make two rows or two columns equal. Right? Here, suppose if I do, guys, C2 minus C1, column 2 minus column 1, right? So in that case, what will I get? If I take C2 minus C1, I can say D is equal to column 2 minus column 1. This is column 2 minus column 1. So 1, 2, 3, column 1 remains as it is. 1001 minus 1 will be 1000. 2002 minus 2 will be 2000. 3003 minus 3 will be 3000. So I have done C2 minus C1. 11, 12, 13. Right? Take 1000 common from C2. If I take 1000 common from C2, I will get D is equal to 1, 2, 3, 1000 common. So 1, 2, 3, 11, 12, 13. Right? Now, since C1 is equal to C2, if any two rows or any two columns are equal, then the value of the determinant is 0. As C1 is equal to C2, therefore D will be equal to 0. This is how you find the value of the determinant without actual multiplication. Let's see another sum, guys. One, 10, 11, 12, 100, 102 and 104. Right? Now, I have to think of ways and means of making any two rows or any two columns equal. First, assume the sum to be D. So let D be equal to 111, 10, 11, 12, 100, 102, 104. Right? Now, suppose if I do R1 minus R2. Right? If I do R1 minus R2, row 1 minus row 2, 1 minus 1, 0, 10 minus 11, minus 1, 100 minus 102, minus 2. Then let us do R2 minus R3. R2 minus R3, 1 minus 1, 0, 11 minus 12, minus 1, 1002 minus 1004, minus 2, 112, 104. Here you can see that R1 is equal to R2. As R1 is equal to R2, the value of D will be 0. Fine, do we get this thing here? Next, prove that 4, 1 minus 3, 3, 5, 7, 4 minus 2 minus 1 is equal to 4, 4, 3 minus 2, 1, 5 minus 1 minus 3, 7. Right? Now, I have to prove these two are equal. So let's start with the LHS, guys. LHS 413357 4 minus 2 minus 1. Right? Now I want, look at your RHS, I want 443. I have 443, but I want it in the row and I have it in the column here. So first thing I'm going to do is interchange rows and columns. If I interchange rows and columns, first row will become first column, second row will become second column, third row will become third column. This is called as interchanging rows and columns. Right? First row becomes first row 413 357 4 minus 2 minus 1. Right? So I have interchanged rows and columns. Fine, do we get this thing clear? Now let's see my right hand side. I want 4 minus 2 minus 1 to be my first column. That's my third column. I'll say that interchange third column and first column C13. This is how you write it. Now when you are interchanging only rows or only columns, then you have to multiply by minus 1. So if I'm interchanging only rows or only columns, I have to multiply by minus 1. So now my third column will become first column 4 minus 2 minus 1, and my first column will become third column 357 and 413. Now if you look at your right hand side, 4 1 minus 3 should be 4 1 minus 3. Right? Now 4 1 minus 3 I want it as my second column. So what I'm going to do now, I'm going to interchange second and third column. If I interchange second and third column, since I'm interchanging only columns, I'll have to multiply by a minus 1. So in that case, this will become 4 minus 2 minus 1, 4 1 minus 3, 357. Minus 1 into minus 1 will give you plus 1, so this will become 4 minus 2 minus 1, 4 1 minus 3 and 357. And that is what I had to prove. Right? That's my RHS. That's how I prove LHS is equal to RHS. Next, let's see another sum, guys. Prove that AX, BY, CZ, X square, Y square, Z square, 1 1 1 is equal to ABC, XYZ, YZ, ZX and XY. Right? Now, let's start with any one of the side. What I'm going to do here, guys, I have AX here and I want A. To convert AX to A, I would have to divide. And if that means if I start with left hand side and if I want to get right hand side, I would have to divide. If I start with right hand side and if I want to get left hand side, I would have to multiply. Since it's more easier to multiply, therefore I'm going to start with the right hand side. Had I started with the left hand side, even then I would have got the same answer. But I just want to make the sum a little more simpler for me. Therefore I'm going to start with right hand side. Right hand side is A, B, C, X, Y, Z, YZ, ZX, XY. Right? Now, look at your left hand side. I want AX in the answer. So I'll say multiply first column by X. So in that case, multiply and divide. To keep the equation constant, I'll have to multiply and divide first column by X. So this is going to be, I'm dividing by X and I'm going to multiply the first column by X. So this will become AX, X square, XYZ. Now, look at your left hand side again. I want BY. So I'll say multiply and divide second column by y. So if I multiply and divide second column by y, I am dividing by y here and I will multiply inside, so this will become by y square and xyz. Then look at your LHS again, I want cz. So I will say multiply and divide third column by z. So in that case this will become cz, z. First of all I'll have to divide outside, now I'll multiply inside, cz, z square and xyz. So I'm multiplying and dividing different columns by different numbers, right? Now if you look at this, I have xyz common in the third row. Take xyz common from third row. So in that case I already had xyz here. I am taking xyz common from the third row. So in which case this will become ax x square 1 by y square 1 cz z square 1. The third row will be 1 because xyz has been removed common from there. xyz gets cancelled, so this will be ax by cz x square y square z square 1 1 1. Right? So this is going to be my right hand side. Oh, sorry, left hand side. I started with right hand side and I got my left hand side. Right? Let's see another sum, guys. Prove that 3 4 5 2 2 minus 1 minus 6 7 4 plus minus 1 5 4 3 2 minus 6 4 2 7 is equal to 4 times 1 1 2 3 2 minus 6 and 4 2 7. Right? Now look at the right hand side. The second row is 3 2 minus 6, the third row is 4 2 7. On the left hand side the second determinant also has the same thing, 3 2 minus 6 and 4 2 7. Right? Now the problem is in the first determinant. So what I'm going to do is, first I'll say let the first determinant be equal to d. 3 4 5 2 2 minus 1 minus 6 7 4. Now minus 1 3 4 I have. Now I want minus 6 3 2, I want it in the row whereas I have it in the column. 3 2 minus 6 I want it in the row and I have it in the column. So first thing I'm going to interchange rows and columns. If I interchange rows and columns, I don't need to multiply by minus 1 because I'm interchanging rows and columns, all the rows and all the columns. So first row will become first column, second row will become second column, and third row will become third column. Right? Each of the row and column will be interchanged. Right? Once this is done, then I can say that I want 3 2 minus 6 as my second row. So I'm going to interchange row 1 and 2. Since I'm interchanging only rows, I have to multiply by minus 1. When you are interchanging only rows or only columns, you have to multiply by minus 1. So in that case, this will become 4 2 7, 3 2 minus 6 and 5 minus 1 4. Right? Now I want 4 2 7 as my third row. So I'm going to now interchange first and third row. Since I'm interchanging only rows, I have to multiply by minus 1. When you are interchanging only rows or only columns, you have to multiply by minus 1. So this will be 5 minus 1 4, 3 2 minus 6, 427. Minus 1 into minus 1 is plus 1. So you will get the answer for this as 5 minus 1, 4. 3, 2 minus 6, 427. Once you have this, now let's see our LHS. LHS is given to you as 3, 4, 5, 2, 2 minus 1, minus 6, 7, 4, plus minus 1, 5, 4, 3, 2 minus 6, and 427. Right? Now the value of the first determinant we found out this value 3, 2, 3, 4, 5, 2, 2 minus 1 minus 6, 7, 4 is nothing but 5 minus 1, 4, 3, 2 minus 6, 4, 2, 7, plus minus 1, 5, 4, 3, 2 minus 6, 4, 2, 7. Right? I substituted the value of the first determinant. I had already found out the value of the first determinant. I substituted that. Now, in these two determinants, the second and the third row is the same. Since the second and the third row is the same, I'll take the second and the third row as common. That means now when I add, I'll have to add only the first row. This will be 5 minus 1, 4, minus 1 plus 5, 4, 4 plus 4, 8. Right? Second and third row I'm taking common. Now take 4 common from first row. Common from first row. If I take 4 common from first row, this is 1, 1, 2, 3, 2 minus 6, 4, 2, 7. That's my RHS. That's what I have to prove. Next, let's see another sum, guys. Prove that 1a square minus bc, 1b square minus ca, and 1c square minus ab is 0. I have to prove that this number is 0. Let's see how do we solve this. Now, when you want to prove 0, try to get as many zeros as possible in the determinant. Right? So let's see the LHS. LHS is 1a square minus bc, 1b square minus ca, 1c square minus ab. Right? I want to get as many zeros as possible. The easiest way for me to get 0 is if I do R1 minus R2. If I subtract first row minus second row, I'll get a 0. So in that case, this will be 1 minus 1, 0, a minus b, a square minus bc, minus b square minus ca. This is R1 minus R2. Suppose if I do R2 minus R3, 1 minus 1, 0, b minus c, b square minus ca, minus c square minus ab, and 1c square minus ab. Right? Now, let's try to simplify this further, guys. This is 0, a minus b. Let's open that bracket, guys. If I open the bracket, this is a square minus bc minus b square plus ca, 0, b minus c, b square minus ca minus c square plus ab, 1c square minus ab. Right? Now, let's rearrange these terms, people. If I rearrange these terms, I will get this as 0, a minus b. This is nothing but a square minus b square plus minus bc plus CA. I'm rearranging the terms. This is 0 B minus C, B square minus C square minus CA plus AB, and this is going to be 1C and C square minus AB. Right, now this can be written as 0 A minus B. Now A square minus B square can be written as A plus B, A minus B. Between the third and the fourth term, I could take C common. If I take C common plus C common, then this will become A minus B. Right? Next, 0 B minus C, B square minus C square is B plus C, B minus C. Between the third and the fourth term, I could take A common. So in that case, I'll get B minus C, 1C, C square minus AB. Right? Here, in the first row, before that, let's simplify this further. 0 A minus B. Now between these two terms, guys, A minus B is the common bracket. So the uncommon bracket will be A plus B plus C. Here 0 B minus C. The common bracket is B minus C. Uncommon bracket is going to be A plus B plus C. 1C C square minus AB. Now I can take A minus B common from first row. Take A minus B common from R1 and B minus C common from R2. So A minus B is out, B minus C is out. So that will remain, first row A minus B is common. So 0, 1, A plus B plus C. Second row B minus C is common. 0, 1, A plus B plus C. 1C C square minus AB. Here you can see that first row and the second row are identical. I can say here R1 is equal to R2. Since R1 is equal to R2, therefore this will be equal to 0, and that's what you have to prove. You have to prove that the answer is 0, which is one RHS. If the value of two rows or two columns is identical, then the value of the determinant will be equal to 0. Fine, do we get this thing clear? Next, let's see another sum, guys. B minus C minus B, 0 A, C minus A, 0 is 0. I have to prove this, right? Let LHS be equal to D. Let us assume that LHS is D. So I can say D is 0 B minus C minus B, 0 A, C minus A is 0. Now first thing I'm going to do is I'm going to take minus 1 common from all the three columns. Take minus 1 common from C1, C2 and C3. If I take minus 1 common, then my D will become minus 1 into minus 1 into minus 1. I'm taking minus 1 common from the first column, so all the signs of first column will change. I'm taking minus 1 common from the second column, so all the signs of second column will also change. I'm taking minus 1 common from the third column, so all the signs of the third column will also change. Minus 1 into minus 1 plus 1 into minus 1 is minus 1. 0 minus B, A, B, 0 minus A, minus C, A, 0. Right? Now, interchange rows and columns. if I interchange rows and columns, then D will become minus, first row will become first column, second row will become second column, third row will become third column. But 0B minus C minus B 0A C minus A 0 is nothing but D. This is my original left hand side, the value that I had assumed as D. Therefore I can say that D is equal to minus D. Right, take the minus D on the other side, so I'll get D plus D is 0, 2D is 0, D is 0, and that's what you have to prove, that the left hand side is 0. Right, let's see another sum, guys. With some number, can someone give me? 7. Show that y plus z, z, y, z, z plus x, x, y, x, x plus y is 4xyz. Now, I have to try to get either as many rows and columns same, or I have to try to get as many zeros as possible. Now, I want to get common numbers. Let's see LHS. Let's start with LHS. Y plus z, z, y, z, z plus x, x, y, x, x plus y. Right? Use C1 plus C2 plus C3. If I use C1 plus C2 plus C3, see this, I'll get common numbers. Y plus Z plus Z plus Y. That means I'll get twice Y plus Z. If I add C1, C2 and C3, I'll get 2Y plus 2Z. Here again Z plus Z plus X plus X. So I'll get 2Z plus X. Then Y plus X plus X plus Y will give you twice Y or X plus Y. Balance as it is Z, Z plus X, X, Y, X, X plus Y. I can take 2 common from C1. Take 2 common from C1. If I take 2 common from C1, I'll get Y plus Z, Z plus X, X plus Y, Z, Z plus X, X, Y, X, X plus Y. So 2 is gone common outside. Now, I need to try to get as many zeros as possible. I have a Y plus Z. If I have to get a 0 here, how will I get a 0 here? If I do C1 minus C2 plus C3, I'll get a 0. See how. This will be Y plus Z minus Z minus Y, that is 0. Z plus X minus Z plus X minus X. So this will give you minus X, because this and this will cancel. X plus Y minus X plus Y. So this will give you minus X again. Z, Z plus X, X, Y, X, X plus Y. Right? Now, once I have this, let's try to get other rows also with similar numbers. Suppose if I do C2 minus C1. Right? So this will be 2, 0, minus X, Z minus 0 is Z, C2 plus C1, let me do. So Z plus 0 is Z, Z plus X minus X will give you Z, X minus X, 0. Similarly, if I do C3 plus C1, Y plus 0, Y, X minus X, 0, x plus y minus x will give you y, right? Now I could take x common from C1, z common from C2 and y common from C3. Take x common from C1, y common from C3 and z common from C2, right? So in which case I will get, instead of x I'm going to take minus x common, 2 minus x, y and z. So in that case this will become 0 1 1 1 1 0 1 0 1, because x, y and z has gone out as common. So this will give you minus 2xyz. Now solve this determinant by actual expansion. I've already explained to you how to do a 3 by 3 expansion. So this will be 0 1 minus 0 minus 1 1 minus 0 plus 1 0 minus 1, right? So in that case you will get this as minus 2xyz, anything multiplied by 0 0, minus 1 into 1 is minus 1, 1 into minus 1 is minus 1, so minus 2xyz into minus 2, minus into minus plus 4xyz, and that's what you have to do, right? Let's see another sum, guys. Do that 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c is equal to abc into 1 plus 1 upon a plus 1 upon b plus 1 upon c. I have to prove this, right? Let's start with the LHS. LHS 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c. Try to get as many zeros as you can, right? I can do r1 minus r2. If I do r1 minus r2, this 1 minus 1 would give me 0. So in that case this will become r1 minus r2. 1 plus a minus 1, a 1 minus 1 plus b will give you minus b. 1 minus 1, 0. In the same step I could do r2 minus r3. 1 minus 1, 0. 1 plus b minus 1 is b. 1 minus c is minus c. 1 1 1 plus c, right? So I have tried to get as many zeros as possible. Now I want, if you look at your RHS, I want I need a, b and c common, right? Suppose if I say that take a common from C1, b common from C2 and c common from C3. So that means the ABC will come out, a common, so this will become 1 0 1 upon a. I have to divide entire first column by a. B common, minus 1 1 1 upon b. C common, 0 minus 1 1 plus c upon c, right? Okay, now once you've done this, let's try to get, I need to get 1 plus 1 by a, 1 by c, 1 by c. So 1 by a, 1 by b, 1 by c. What we do is, if I have to get all these three terms together, look at your RHS. I generally look at the RHS to understand what step I have to do next. Do C1 plus C2 plus C3. So in that case, ABC as it is, minus plus 1 minus 1 plus 0 is going to give you 0. 0 plus 1 minus 1, 0. And this will be 1 upon A plus 1 upon B plus, guys, 1 plus C upon C. balance as it is, minus 1, 1, 1 upon b, 0, minus 1, 1 plus c upon c. Right, do we get this thing clear? Now, once I have this, I can say that this can be written as ABC 0, 0, split the numerator here, in which case I'll get 1 upon a plus 1 upon b plus 1 upon c plus 1, right? Minus 1, 1, 1 upon b, 0, minus 1, I'm splitting the numerator, 1 upon c plus 1, because it will be 1 upon c plus c upon c. C upon c can be written as 1, right? Take 1 upon a plus 1 upon b plus 1 upon c plus 1 common from first column. The other two numbers are 0, so I can take common. So I'll get a, b, c into 1 upon a plus 1 upon b plus 1 upon c plus 1. That will give you 0, 0, 1, minus 1, 1, 1 upon b, 0, minus 1, 1 upon c plus 1. Right? Now, once I have this, I could just solve the determinant. This is a, b, c, 1 upon a plus 1 upon b plus 1 upon c plus 1. Solve this determinant. You know how to solve a 3 by 3 determinant. This will be 0. This is 1 by c plus 1 minus 1 by b, minus into minus 1 plus 1. This is going to be 0 plus 1 plus 0. This is 0 minus 1. So this is ABC 1 upon a plus 1 upon b plus 1 upon c plus 1. Anything multiplied by 0, 0 plus 1, anything multiplied by 0, 0. Hence your answer will be ABC 1 upon a plus 1 upon b plus 1 upon c plus 1. And that's what you have to prove. Right? Let's see another sum, guys. Show that a plus b plus 2c, c, a, b plus c plus 2a, b, c plus a plus 2b is equal to twice a plus b plus c the whole square. I have to prove this. Guys, try to get as many zeros as possible. As soon as you get the sum, first thing you have to think is, how can I get as many zeros as possible? Let me write the LHS first. A plus b plus 2c, a, b, c, b plus c plus 2a, b, c, a, c plus a plus 2b. Right? I need to try to get as many zeros as possible. I can say that R1 minus R2. If I do R1 minus R2, it will become a plus b plus 2c minus c. That will give you a plus b plus c. A minus b minus c minus 2a. That will become minus b minus c minus a, because plus a minus 2a will give you minus a. And b minus b, 0. I got 1 0. Next, if I do R2 minus R3, c minus c will give you 0. B plus c plus 2a minus a will give you b plus c plus a. B minus c minus a minus 2b will give you minus c minus a minus b. C a c plus a plus 2b. Right? So I've got as many zeros as I could. Now, from the first row I can take a plus b plus c common. Take a plus b plus c common from R1 and R2. In R1, if I take a plus b plus c common from R1, a plus b plus c common from R2, this will become 1, this will become minus 1, 0, because that minus b minus c minus a is nothing but minus common a plus b plus c. Then this will become 0 1 minus 1 c plus a plus 2b, right? So in that case you will have a plus b plus c the whole square, 1 minus 1 0 0 1 minus 1 c plus a plus 2b. Can I get any more zeros here? I want my answer as a plus b plus c the whole cube. Guys, just make this correction. I want a plus b plus c the whole cube in the question. I need another a plus b plus c. C1 plus C2 plus C3. If I add the three columns, a plus b plus c the whole square, add plus 1 minus 1 plus 0 0 0 plus 1 minus 1 0. This is going to be twice c plus a plus b, because this will be 2c plus 2a plus 2b. I have taken the 2 common to give you c plus a plus b. Minus 1 1a 0 minus 1 c plus a plus 2b. Right? Now I could take 2 a plus b plus c common from c1. Take 2 a plus b plus c common from c1. In that case I'll get twice a plus b plus c the whole cube. 0 0 1 minus 1 1 a 0 minus 1 c plus a plus 2b. Right? Now let's see this. Now I could solve the determinant as it is. If I solve the determinant, this is going to be twice a plus b plus c the whole cube, 0 c plus a plus 2b, principal diagonal minus the other diagonal, minus of minus 1 plus 1, 0 minus into minus plus 1 plus 0, anything multiplied by 0 0 0 into a minus 1. So in that case this will be twice a plus b plus c the whole cube, anything multiplied by 0 is 0, plus 1 plus 0, that will give you twice a plus b plus c the whole cube. And that's what you have to put. Right? Okay, we'll stop this here for the day. Thank you very much.